2030, there could be a nuclear reactor on the moon. First of all, I'm not joking actually. Also, it's not maybe or theoretically. NASA has already picked the companies, the contracts for prototype designs are signed, and the countdown has begun. But when it pours on, everything changes. Right now, 3 companies are building early reactor prototypes. China is racing to beat the US there. And here is the crazy part, the reactor is designed to run for 10 years straight. No refueling, no repairs, just constant power in the most hostile environment humans have ever tried to colonize. But here is what nobody is talking about. This isn't really about the moon at all. But before we figure it out what this actually about, if you don't subscribe to my channel, just subscribe. Okay, now let us find out what this actually about. Quick question, how long do you think night lasts on the moon? 14 days, 2 full weeks of complete darkness. Solar panels work during the day, but when night comes, they are useless unless packed with massive batteries or fuel cells. NASA studies shows that powering even a small habitat through that period with batteries alone would require so much extra mass and cost it becomes highly impractical. That's why NASA is turning to nuclear power fusion reactors that can deliver continuous reliable power through the darkest and most hazard conditions. Here is what's really happening. NASA's Artemis program plans for 40 to 100 kilowatts of continuous power on the moon. That's roughly what 40 average homes use. But on the moon, it can run life support, communication gear, labs, and even mining tools. The reactor design is compact, still a few tons of hardware, including shielding and radiators. In 2022, NASA awarded about $5 million each to Lockheed Martin, Westinghouse, and IX, a joint venture of Intuitive Machines and X Energy, which also includes partners like Maxa or Boeing in that venture, to design the systems which must survive launch, lunar landing, and operate reliably for up to 10 years without refueling. The official target is deployment by 2030, but it remains an ambitious goal rather than a locked schedule. China announced the lunar base plan for 2035. Russia is partnering with them. India just landed near the South Pole. Whoever gets reliable power first basically wants the moon's best real estate. Why? Because the South Pole has water ice that can turn that into rocket fuel, and suddenly the moon becomes the gas station for Mars missions. Think about it. Launching from Earth costs $10,000 per kilogram, but launching from the moon almost nothing. The country that controls lunar fuel productions controls deep space exploration, and it all starts with one nuclear reactor. The reactor splits uranium atoms, the same process that powers submarines, just shrunk down. But here is the engineering nightmare. On Earth, we use water to cool reactors, but the moon has no water, no air, nothing. So they are using heat pipes filled with a liquid metal. The heat travels up, gets radiated into space, and circles back. Basically, it's like a giant radiator floating in a vacuum. The uranium lower rich, basically impossible to weaponize. Even if the rocket exploded on launch, the radioactive material stays sealed in multiple protective shells. But the real challenge is lunar dust. This stuff is a nightmare for machinery. Microscopic jagged glass pieces that cling to everything thanks to static electricity. Doing Apollo missions is scratch visors, dirt space chutes, clogged instruments, and even caused allergic reactions. So the NASA now come with a solution. The solution is burying the reactor. Dig a hole, drop it in, cover it up. Well, the lunar soil actually becomes shielding against the cosmic radiation. So the problem solved. Except nobody's ever dug a hole on the moon before. So add that to the to-do list. Day 1. With nuclear power, we can run 24/7 operations, no more shutting down for lunar night. Year 1, we are mining water ice, producing oxygen and hydrogen. A lunar base becomes self-sufficient for air and water. Year 5, we are manufacturing rocket fuel. Mars missions can refuel in lunar orbit, cutting costs by 19%. Year 10, with enough reactors, we are 3D printing entire habitats from lunar concrete. The moon becomes a construction site for deep space missions. But these goals are part of NASA's roadmap and concept studies, not firm deliverables. So here is the plot twist nobody sees coming. The tech we develop for the moon solves problems on Earth. Remote Arctic bases, disaster zones where the grid's destroyed, deep ocean exploration, even Mars colonies. They all need compact, reliable nuclear power. The moon reactor becomes the prototype for energy independence anywhere. And politically, the country that proves safe, portable nuclear power could own the future of energy, not just in space, everywhere. Let us be real though. This could fail, the rocket could explode, the landing could fail, the reactor could malfunction. One design and we got a dead reactor on the moon with no way to fix it. But NASA has a potential backup plan that could send multiple reactors. If one fails, the other keep running. Yeah, it's expensive, but cheaper than sending repair crews. Meanwhile, China's groundwork mission Chang'e 8 in 2028, making it an early step toward the nuclear power lunar base. So here is the question and drop your answer in the comments. If you could build anything on the moon with unlimited power, what would it be? Because in 5 years that question stops being hypothetical. The reactor could land in 2013, the power turns on and for the first time in human history, we have a permanent foothold beyond Earth. Not because we visited, but because we stayed. The nuclear age in space starts now. The only question is, who gets there first? But if you like this video, just subscribe, like, share. Bye everyone.